I'm very pleased to be able to come here and present the work that the Basler AG themselves did over the last few years we chose a sensor and integrated it, and I wanted to share some of the information, some of the experiences we had with that in this talk. I'll just start. I'm allowed to do one transparency to tell you who we are. We're actually a company who makes a large different number of cameras, just cameras which produce pictures, images in the memory for the customers, especially in machine vision areas and also in medical areas. As you can see, we have a large portfolio of different cameras of different types, different back ends, different front ends. What you won't see in this picture, because the camera didn't make it to the photo shoot, is our 3D ToF time-of-flight camera. And that's what this presentation is about. But 4 years ago, we didn't have any 3D cameras, and we were thinking about doing a 3D camera. And one of the first things we did is we got a Kinect and had a look at it. I remember this quite clearly. I took it home, wired it up to the TV, and then started playing around with it. And then for the first time, my son, who was 10, got really interested in what I was doing at work with a Kinect camera there. And we used it and we looked at this 3D stuff. And I think this is important because everybody wants to communicate with computers and stuff in 3D. That we live in a 3D world. We want to react in this dimension as well. And this is, for me, why 3D is important. Everybody can understand the world is not flat. So all of these cameras produce flat images. And what we want to do is produce a camera that wasn't flat. Now, we went through the same process, which Chris Osterwood explained this morning about how do I choose which kind of 3D camera do I want to use. And we said, well, we're going to look at stereoscopic, we're going to look at LiDAR, we're going to look at all of these stuff. And we came out at the end, for our market and what we wanted to do, we came up with a ToF camera was necessary. And so we went about to design a ToF camera. This talk is for absolute beginners. Okay, there's not going to be anything complicated. There's going to be some physics. There's going to be some tricks to avoid, some things to do, lists and lists of sensors and data for you to look at afterwards. But I'm not going to be able to describe 4 years' work from 10 people in about 40 minutes. So this is a very, very rough overview from what happened. So I'm going to start off with an extremely basic what is ToF, with pictures from Wikipedia, as you do these days. Then I'm going to talk about remember how fast the speed of light is and why this is relevant to building a ToF camera. Synchronization, lighting, shutter effects, everything you have to pay attention to when you want to build a camera with a ToF sensor, or I always say camera, but anything with a ToF sensor, this is relevant. I'm going to detail which sensors are commonly available. In the case of ToF sensors, this is a very new technology. Some of the sensors are very difficult to get hold of. Some of the information of the sensors is very difficult to get hold of. Some of them are still very secretive. More about that later. And then at the end of it, I hope you realize this is a lot of hard work to integrate these sensors, and you may want to have a look at people who have already done this, and then maybe think about just buying the whole work already done in the form of a ToF module. And I'll talk briefly about that. And then when you're really, really excited about ToF sensors or modules or cameras, there's a few things you have to be careful about when you use more than one of them in the same room at the same time. And we'll come to that at the end.